this will give you the velocity in Cartesian coordinate system orthogonal. This is an orthogonal coordinate system. Keep it in mind. Fine. So we will get the velocity equal to this. Now we have to calculate the acceleration, and acceleration means the double differentiation of position vector. So first differentiation we got this. Now we have to differentiation it again. We will differentiation this very equation again with respect to time. Say this is equation A. Differentiating equation A with respect to time again. Okay, so what will we get? We'll get differentiation. First differentiation we got this, then the double differentiation with respect to time, that we get double dot. So our double dot will be equal to what? A is still constant times. Now again differentiation of sine, cosine, and theta, it's theta dot. We'll get cosine theta theta dot, but minus times. So we'll get cosine theta theta dot I. Okay, but I'm not writing down theta dot here because it will come outside. Fine. So plus cosine of theta, its differentiation is minus times sine, so it will get converted to minus sine into theta dot j. But theta dot is, I'm keeping it outside from this also, keep it outside the brackets. So we'll get theta dot outside and also a theta here. Fine. Theta dot into theta dot will be theta dot square. Okay, plus from the chain rule of the differentiation, first we have to differentiate this, keeping this constant, and then this differentiating this, keeping this very thing as it is. Fine. So differentiating this into this. Now we are keeping this very thing as it is, differentiating this very thing. So we'll get minus sine theta I plus cosine of theta j into differentiation of theta dot. Theta dot is differentiated again with respect to time, so we will get theta double dot. Fine, because it is differentiated again with respect to time. So from here, keeping this minus and minus outside, we'll get here cosine of theta plus sine of theta. Fine, and cosine of theta plus sine of theta is already known to you as, I'll write it down first. Our double dot will be equal to minus times a cosine of theta I plus sine theta j theta dot square. So this very thing, a times this very thing, it is from here, it is r, it is the position vector itself. Okay, so plus here minus times sine theta of I cosine of this and theta dot square. This very thing, where it is, this very thing I have told you, minus times sine plus cosine of theta, it is represented, it is it gives the direction of the increase in theta denoted by this very thing. So this is theta hat and this is our vector. So we will substitute here theta hat or into theta double dot. Okay, and I'm missing something here. Sorry, I have double differentiated with this, but I have missed here. It is a here also, because a is constant in both the cases. Fine, so it is a here. Hope you are getting my point. Here a double differentiation, we are getting this very thing, and from this we know this is the position vector itself. So double dot of r will be equal to minus times this will be r vector into theta dot square plus a times this a times, I will write it down this very first, and theta dot. This will give the position vector along the circular path acceleration of that. Okay, double differentiation of this position vector will give the acceleration along the circular path. Fine. So now there is a special case arising from this very thing. Let us see what that is. Fine. So we have got the result. I will write it down again. R double dot. This is the acceleration. R double dot will be equal to, now it is given as minus theta dot square R vector plus a theta dot double dot and theta hat, unit vector along the theta axis, you can say. So considering that the circular motion is uniform, fine, this is, say, equation A prime. So consider the case that circular motion is uniform. So what will we get? We'll be getting, that means circular motion, we have change in the theta with respect to time gives the velocity, that is the angular velocity. Okay, angular velocity. Fine. And double differentiation of this very thing gives the acceleration. Fine. So double differentiation, that is the theta dot, and now double differentiation will give the acceleration. But this is written as d by dt of theta dot. Fine. So we are considering that the circular motion is uniform, that is velocity of the particle is constant, that is the angular velocity here, because it's moving in the along the circular path. So we have to consider that velocity is constant, that means theta dot is constant. Fine. So that means theta dot is constant, and we know the differentiation of a constant term is always 0. That means this very term will lead to d by dt of dt, d by d theta dot of dt, that the double dot will be 0, because theta dot is constant, that is angular velocity is constant, because the particle is moving with along the circular path with uniform velocity. So from the equation first, what we'll get from this equation, double dot r will, this term will vanish because theta double dot is 0. So from this very equation, r double dot will be equal to minus times theta dot square r vector. This will be the acceleration, even though the magnitude of the velocity is constant, but still then there is an acceleration. This is the circular path, particle is moving with velocity, constant velocity, okay, but still then it is facing an acceleration, and that acceleration is brought in by this very component, okay, because the direction is still unchanging, still going unchanged, even though the magnitude is kept constant, and this very term gives the acceleration along the circular path, even though the velocity is uniform. Circular path, the magnitude is constant, but there is a still acceleration felt inside this body, and this very acceleration is caused by the force, and force, we know force is the mass times the acceleration, Okay, so in this case F will be equal to minus times mass times mass of the body times theta dot square, or because acceleration here it is minus times this very thing, so force will be equal to this. And it is also written as F is also written as minus times m theta dot what is theta dot? This is the change in the angle with respect to time, that is the angular velocity. Fine, angular velocity. And here angular velocity we also represent it as omega, that's m omega square or vector. This gives the force, this is the force which produces the acceleration inside the body even if it is moving with constant velocity. This force is called as the centripetal force, okay? Centripetal force. And the acceleration which it produces is called as centripetal acceleration. We can call it as centripetal acceleration because this acceleration is caused by the centripetal force, and this force is equal to and given by this very thing. Because the component here, this very is vanished, but still then one component is still existing, and this gives the acceleration, and this gives the acceleration produced inside this body even though it is moving with constant velocity. So this was all about the acceleration and velocity of a particle moving along the circular path in the orthogonal coordinate system, and how the centripetal force is producing this very acceleration inside the body. Okay, that's all for today. Thank you.